Hello everyone. In this session we are going to see vector calculus. Vector calculus is classified as two subdivisions. One is vector differentiation and another is vector integration. In this session we see vector differentiation. This is a basis for engineering study, and the operators which we are going to see says how the fields behave in this case. First we are going to see del operator. Del operator is denoted by del, the symbol del. Del operator denoted by the symbol del. It is defined as I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Vectors are denoted by cap, I cap, otherwise I vector like this, j vector and k vector. So based on this del operator, we are going to see three key operations, namely gradient, divergence and curl. Gradient denoted by del phi. It is gradient of scalar point function phi. Divergence is denoted by del dot f vector. So it is a dot product of the del operator with the vector quantity f vector. And curl is del cross f vector. Curl is denoted by del cross f vector. Okay, now we are going to see gradient, divergence, curl one by one. First we are going to see what is the definition of gradient and what are the other terminologies we can study based on gradient. Gradient of scalar potential is denoted by del phi and it is defined as dou phi by dou x into I vector plus dou phi by dou y into j vector plus dou phi by dou z into k vector. This del phi is a vector quantity. This del phi is a vector quantity. It is a vector quantity. And from this gradient, we can find out what is the directional derivative. Directional derivative directional derivative. Directional derivative can be found by del phi dot a vector, which is a direction vector, divided by modulus of a vector. Then next, using this gradient of scalar potential, we can find what is the maximum directional derivative by finding what is the magnitude of gradient of scalar potential. Next, we can find what is the unit normal vector to the surface. Unit normal vector. Unit normal vector usually denoted by n cap. N vector, otherwise n cap. And this is denoted by del phi. This is denoted by n cap and it is defined by del phi divided by modulus of del phi. And using this gradient of scalar potential and knowing how to find what is the magnitude of this, we can even find what is the angle between two surfaces. Angle between two surfaces. Taking surface 1 as phi 1 and taking surface 2 as phi 2, we can find what is the angle between two surfaces. by using this gradient of scalar potential. Next we are going to see divergence. Divergence denoted by del dot product of f vector. F vector is a vector quantity. This del is the del operator operated on f vector. Del dot f vector represents the amount of flux that diverges per unit volume in unit time. And this quantity del dot f vector is this dot product. Del dot f vector is a scalar quantity. It is a scalar quantity. It is a scalar quantity. So del is the operator which is defined as I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z, which is operator on f vector. For instance, I am taking f vector as f1 I vector plus f2 j vector plus f3 k vector. So the dot product will give you this del operator is dou by dou x, j vector dou by dou y actually. I will not come here. And here it is dou by dou z. This operator is operated upon f vector. So dot product will give you this dou f1 with respect to x plus dou f2 with respect to y plus dou f3 with respect to z. When f vector is a constant vector, then this divergence of f vector is equal to 0. The other notation of divergence of f vector is div f vector. If f vector is a constant vector, then divergence is equal to 0. Next we are going to see curl. Curl of a vector quantity f vector. Curl implies rotation of a vector, which is denoted by del cross f vector. Curl of f vector is denoted by del cross f vector, which is defined by determinant ijk, first row, second row, the coefficient of ijk in del operator, third row, the coefficient of ijk in f vector. Then finding the determinant will give you what is the curl of f vector. This is a vector quantity, which is a vector quantity. An example is given below. The example says that place a tiny paddle wheel in the floor. If it spins, curl is non-zero. So if it rotates, curl is non-zero. If curl is 0, then there is no rotation. As an application of divergence and curl, we are going to see two terminologies named as solenoidal and irrotational. Solenoidal vector, rotational vector. So when we say vector f vector is solenoidal means if the divergence of f vector is 0. So a vector is said to be a solenoidal vector when the divergence vanishes. So that is divergence of that vector f vector is equal to 0. So the other notation of this is del dot f vector equal to 0. As an example, in compression flow, fluid density is constant. What enters a region must exit. So similarly, the other example is magnetic field. and the continuity equation. Next comes irrotational. This is based on curl. So a vector is said to be irrotational vector when the curl vanishes. So curl curl of f vector is equal to 0. So the notation of curl is del cross f vector is equal to 0 vector, means we'll say that this vector f vector is irrotational. This 0 is a vector 0. 0 vector means 0 I vector plus 0 j vector plus 0 k vector. So irrotational means the curl is 0. Next we'll see examples based on how to find out divergence and curl. If divergence is equal to 0, we'll conclude the vector f vector is solenoidal. If curl is equal to 0, then we'll conclude the vector f vector is irrotational. So for an example, we have taken f vector as x into I vector plus y into j vector plus z into k vector. So first we are going to find divergence of f vector. Divergence of f vector denoted by del dot h vector. So how to find the dot product? We need to find I dot I, j dot j, k dot k. Other dot products are 0. So I dot I will give you dou by dou x of x. This dou by dou x is the coefficient of I vector in del operator. This x is the coefficient of I in f vector. So dou by dou x operated on this variable x. Similarly, j dot j will give you dou by dou y of y. Y is the coefficient of j vector in f vector. Then this z is the coefficient of the vector. So if we do the dot product, we will get dou by dou x of x plus dou by dou y of y plus dou by dou z of z. So if you partially differentiate x with respect to x, you will get 1. Partial differentiate y with respect to y, you will get 1. Partial differentiate z with respect to z, you will get 1. So altogether it is equal to 3. So it is equal to 3, so not equal to 0. Therefore, divergence exists, but it is not equal to 0. So it is not, vector is not solenoidal. It is equal to 0, we can conclude that it is solenoidal. Next we are going to see how to calculate curl of f vector. Curl of f vector. So the same f vector xi plus yj plus zk. Curl of f vector is denoted by del cross f vector. So how to find out the cross product? Using the determinant. First row, as usual, we should write I vector, j vector, k vector. Second row, we need to write the coefficient of I vector, coefficient of j vector, coefficient of k vector and del operator. Third row, we need to write coefficient of I vector, j vector and k vector and f vector. Then we need to find what is the determinant of this. So how to find the determinant? Take I vector, first row, leave the first row and first column. Then we need to cross multiply dou by dou y of z. So if you operate this operator on z, you will get 0 minus dou by dou z of y. So partially differentiating with respect to z, other variables are constants. So you will get 0. Then next minus j vector into, leave the first row second column, dou by dou x of z you will get. So partial derivative is 0 minus dou by dou z of x you will get. So partial derivative is 0. Because differentiating partially with respect to one variable, you should treat the other variables constant. Then next plus k vector into cross multiply Partially differentiate y with respect to x, you will get 0, minus if you partially differentiate x with respect to y, you will get 0. So altogether 0 I vector, 0 j vector, 0 k vector, 0 I vector plus 0 j vector plus 0 k vector. So altogether this is equal to 0 vector. So curl of f vector we are getting a 0 vector, so we can conclude that the vector is irrotational. These are few applications in engineering side for the del operator and gradient, divergence and curl. Maxwell's equation uses all these three operators, and this divergence governs continuity, and curl has many applications in engineering side. Then structural analysis deals with stress and strain tensors, which relies on gradient and divergence to model deformation and failure. So as a conclusion, the gradient, divergence, curl based upon that solenoidal and irrotational as major applications in engineering. Thank you.